Hello everyone, thank you for taking the time to join us today. We are excited to present our project, the VetCare Hub Database System. Before we begin, allow us to introduce ourselves. Our team consists of 5 members, Muhammad Daniel, Amirul Amir, Muhammad Akil, Ahmad Deni, and myself, Zahan Zikri. Together, we work diligently to create an innovative solution that aims to modernize veterinary care. Welcome to the presentation of the VetCare Hub. In the dynamic and evolving field of veterinary care, traditional method of managing animal health often prove to be inefficient and prone to errors. These challenges inspired us to develop VetCare Hub, a system designed to automate and centralize key veterinary process. Our system streamlines tasks such as appointment bookings, maintaining medical record, monitoring disease outbreaks, and managing payment. By doing so, it ensures timely and effective care for animals. VetCare Hub also offer a user-friendly interface. You offer user-friendly interface, disease control mechanism, and a digital library to support veterinarians and pets owners alike. The ultimate goal is to enhance efficiency, improve health outcome, and support operational excellence in veterinary practice. Okay, for the scope of the VetCare Hub database system is centered on modernizing veterinary health management. It automates processes such as maintaining health record, scheduling treatment, tracking vaccination, and monitoring disease control. Through decentralized platform, users gain a real-time access to vital data, significantly enhancing decision-making, diagnosis accuracy, and care delivery. For the user scope, VetCare Hub serves two key user groups, veterinarians and pet owners. For veterinarians, the system acts as a powerful tool to manage health record, monitor disease, issue prescription, and track the progress of treatment. This ensures that they can deliver accurate and timely care to the animals under their supervision. For pet owner, VetCare Hub simplifies their responsibility by providing access to health record and vaccination schedule. They receive reminder for upcoming treatment, can book appointment with ease, and make secure online payment. The system enhances convenience for pet owner while ensuring better care for their animals. Okay, next we are going for the objective. The primary objective of VetCare Hub are to enhance the efficiency of veterinary operation and improve the overall care experience for both veterinarians and pets owner by centralizing the management of animal health, appointments, treatments, and disease outbreak. The system address inefficient in traditional method. So the platform is designed to provide veterinarians and pets owner with intuitive access to vital health data and service. It's modernized disease control by enabling real-time tracking to infectious disease, vaccination, and treatment, which support effective prevention strategies. Additionally, VetCare Hub simplify appointment scheduling and billing, reducing administrative tasks and making the process more convenient for pet owners. Veterinarians are also empowered with analytic tools to monitor health trend and make informed decisions, enabling proactive and effective care. In summary, VetCare Hub is a comprehensive solution that prioritizes efficiency, accuracy, and user satisfaction.
Hello everyone. Right now, I will be presenting about the entity relationship diagrams and the enhanced entity relationship diagrams of our project. So, let's start with the ERD. This diagram models the key entities, their attributes, and relationships in the system. So, this ERD serves as the foundation for organizing and structuring our database of the project. So let's look at the key entities and relationships. We can see the owner and animal. The owner entity identified by the primary key or the ID can have a one-to-many relationship with the animal entity. This means one owner can have multiple animals, but each animal belongs only to one owner. Next, we have the animal and appointment relationship. The animal entity also has a one-to-many relationship with the appointment entity, which allows each animal to have multiple appointments, but each appointment is specific to only one animal. Next, appointment and vet. The vet entity, identified by the primary key vet ID, can handle multiple appointments, but each appointment is assigned to a single vet. Then we have diagnosis and treatment, where each diagnosis can lead to multiple treatments, capturing the prescribed medical actions. Similarly, a diagnosis can have multiple prescriptions, but each prescription is tied to only one medication. The vaccination records, the identity, the entity of vaccination record tracks records for each animal, and the veterinarian are just meeting them. So to summarize, the ERD captures relationships such as one to many, and the necessary foreign keys to enforce referential integrity for this ERD. So now we will move on to the enhanced entity relationship diagrams of our project. So we introduce a superclass which is person, which is you can see on the top, to capture attributes common to both owner and vet. Attributes such as person ID, name, address, and phone number are centralized inside the person entity. So the subclass owner and pet. The owner subclass inherits from person and represents individuals who own animals in the system. The vet subclass also inherits from person and includes attributes specific to veterinarians such as license number and specialization. So in our system, the generalization between person and the subclass is marked as disjoint, which is D, meaning an animal can either be an owner or a vet, but not both. So why do we use EERD in our project? The EERD improves upon the ERD by eliminating redundancy. For example, attributes like name and address are defined only once in the person subclass, making the designs cleaner and more efficient in this project. So to conclude, the ERD captures the overall structure and relationships inside the system, while the ERD enhances it by introducing generalization for better organization. This database design ensures scalability and consistency while meeting the system's functional requirements. Thank you.
Hello everyone. Today I'm going to walk you through the database design for veterinary management system. This system organizes and simplifies data management for animals, their owners, veterinarians, diseases, treatments, and more. Let's start with the primary keys, which uniquely identify each record in our database tables. In the owner animal table, the primary key is composite key of owner ID and animal ID. The diagnosis table uses diagnosis ID as its primary key. The payment tables relies on payment ID. Similarly, the vet diseases table uses a composite key of vet ID and diseases ID. Now, let's discuss the dependencies in our data structure. For partial dependencies, these occur when non-prime attributes depends only on part of composite primary key. For instance, in the owner animal table, owner ID determines details like owner name, owner address, and owner phone. In the vet disease table, vet ID determines attribute like vet name, vet specialization, and vet phone. For transitive dependencies, these arise when non-prime attribute depends indirectly on prime key. Example include in the vet disease table, vet ID indirectly determines vet name via vet specialization. In the diagnosis table, disease ID indirectly determines diagnosis details to disease system.
In our VetCare Hub project, we've applied the principle of database normalization to optimize the structure and efficiency of the system. We started it with 1NF, where we initially combined various attributes such as animals and the owner details, diagnosis, treatments, and payments into a single table called animal care. However, this resulted into redundancy and inefficiency. To solve this, we moved to 2NF by decomposing these tables into smaller, more focused tables. For example, we created the owner animal table to store owner and animal details, and the vet disease table to link veterinarians with disease. Additionally, we introduced the diagnosis treatment table to connect diagnosis and treatments. To ensure we address all dependencies, we handle partial dependencies. For instance, in the owner animal table, the owner ID determines attribute like owner name, owner addresses, and owner phone. Similarly, in the vet disease table, vet ID determines the vet name, vet specialization, and vet phone. By removing these partial dependencies and separating them into distinct tables, we adhered to 2NF. Next, we move to 3NF, where we eliminated transitive dependencies. A transitive dependency occurs when one non-key attribute depends on another non-key attribute. For example, in vet table, vet ID determine vet specialization. Then, vet specialization determine vet name, form a transitive dependency. So we remove it by creating a separate table for vet and specialization. Similarly, in the diagnosis table, disease ID determine disease system and disease system determine diagnosis details is a transitive dependency. So we separated the symptoms and details into their respective tables. Finally, our 3NF structure now includes separate tables for owner, animal, vet, disease, diagnosis, treatment, vaccine, medication, and others. This ensures that every non-key attribute is fully dependent and on the primary key and eliminates both partial and transitive dependencies. By following these normalization steps, we ensure the VetCare Hub system is efficient, reduces redundancy, and promotes data integrity, allowing both veterinarians and pet owners to manage animal health records seamlessly. So that's all from me. Thank you.
Morning. My name is Muhammad Akil bin Muhammad Ashraf, and for today, I will be presenting on the SQL script for the data definition language, also known as DDL. So, for the first part is the create function, specifically the create table function. The create table function is an SQL statement used to define and construct a new table within a database, specifying its name, column, data types for each column, and optional constraints like primary keys, foreign keys, or unique indexes, essentially creating a structured storage area for data within the database. So I've prepared three different codes for three different tables. The first table is animal, which contains animal ID, name, species, breed, age, weight, gender, and also owner ID. For the second table is owner table, which contains owner ID, name, address, phone number, and email. For the third table, I have the vet table, which contains vet ID, name, specialization, phone number, and also email. So the first example is the payment table, which contains payment ID, appointment ID, amount, payment date, and payment type, and also status. So once this code have been run, and you will be left with this table. So as you can see, there's no values and or data in the table. This is because we have not inserted any data and or values in the table. And as a result of this, we are left with the table which only contains null values. Another example is the prescription table, which contains prescription ID, diagnosis ID, medication ID, dosage, and also instructions. Again, there's no data and or values in the table since we have not inserted anything in the table, so there's only null values in the table. For the next part is the insert function. An insert function is a SQL statement used to add new rows of data to a table within a database, essentially allowing for inserting new records with specified values into a designated table. So for the first example is we want to insert the values into the owner table. So as you can see, the first one is the name, the second part is the address, the third part is the phone number, and the last part is the email. So as you can see, John Doe, Jane Smith, Paul Brown, Emily White, and until William Reid falls under the name column. For the second part, 123 Pet Street, 456 Animal Ave, 789 Pet Park, it all falls under the address column. So for the phone number 012, 012, 013, it all falls under the phone number column. And also the John Doe at example, Jane Smith at example, until William Reid at example, it all falls under the email column. Another example is the animal table. Again, Bella, Max, Charlie, Milo, and until Luna, it all falls under the name column. For the species, there's dog, cat, dog, cat, dog, cat, until the last one is cat. For the breed is the specific breed of the animals. For the age is the age of the animals. For the weight is the weight of the animals. For the gender is the animal's gender. And also, lastly, is the owner ID, which correlates to the owner table right here. For the next part is the alter and drop function. The alter function, firstly, the alter function allows you to modify the characteristics of an existing stored function, like changing its definition or properties without deleting it, while the drop function permanently deletes a stored function from the database, essentially removing it completely. So, if we combine these two functions together, we can alter a certain table and drop a certain column and or row. So for this example, I will be altering the table animal, the animal table, and I'll be dropping the gender column. So as you can see, once this code have been run, the output is as shown on the right side, with the columns only being animal ID, name, species, breed, age, weight, and also owner ID. As you can see before, originally the animal table contains gender in between weight and owner ID. But once this code have been run, in between weight and owner ID, the gender is nowhere to be seen since it has been dropped from the database, from the table. And finally, the print function. This is in order to show the tables that have been created. So select star from owner shows the owner table, select star from animal shows the animal table, and so on and so forth until the referral. So these owner, animal, vet, diseases, and until referral, these are the names of the table that's in our database. And the star refers to everything in this said table. So, for example, select star from animal shows you the whole animal table. But if you want to see only certain columns of the table, you can run the code select species from animal, which then only shows you the species column. All right, that's all from me. Thank you.
Assalamualaikum and hello to everyone who is watching, especially hello to you, sir. My name is Muhammad Amirul Amir bin Muhammad Husni, and I will be presenting on the data manipulation language part of our SQL. Okay, so for the first DML function, we decided to use update function. This update function is great when we want to update the attribute of a table. For instance, in this case, we wanted to update the phone number of the owner from his previous phone number to his new phone number, and his name is John Doe. So how would we do it? We just this is how we would write the syntax, which is update owner table. We set his phone number to his new phone number when name equal to his name, and as you can see from the output here, at the top of the list, we have John Doe with his new phone number instead of his old phone number. Okay, next is another update function. This one is different. This one is we update the whole column instead of just for one person. So in this case, let's say the prices for vaccine have increased by $5. So it would be troublesome to update the cost of each vaccine one by one. So instead we update the whole column uh, at once. So how we do it? We update the vaccine table and we set the cost equal to cost plus 5. Let's say the cost has increased by $5 for each vaccine, and this is the result that we will get. As you can see here, the rabies vaccine have become $25. Distemper vaccines have become $20. Uh, Leptospirosis vaccine have become $30. Okay, the next function is the delete function. Okay, for this function, we want to delete two things. The first thing is we want to delete the vaccine, and another one is we want to delete the manufacturer. Okay, for to delete the vaccine, just one vaccine, we use delete from vaccine table where name equals to rabies vaccine. And when we run that, you can see in this table there is no rabies vaccine exists in the name column. Okay. For the when we want to delete the manufacturer, let's say we no longer want to work with for that fact. We have issues or personal reasons as to why we don't want to work with that manufacturer anymore. So we want to delete the manufacturer from our database. So this is how we do it. We delete from vaccine where manufacturer equals to for that fact. And as you can see from the table over here, in the manufacturer column, there is no manufacturer name for that fact. Okay, next is order by function. In this function, we want to list down the animal name and sort it by ascending order. So how we do it is we would select animal ID and name from animal, and then we would order it by name. And because we want it to be in ascending order, we write down ASC. So as you can see from the output over here, the name column is in ascending order, starts with P and ends with R. It is in ascending alphabetical order. And if you look at the animal ID column, it is not in order because we did not order by animal ID. Okay, so the next function is for the condition. The purpose of this function is to analyze the animal group by their species. And it also will calculate the average weight and total count of animal for each species. And we will apply the condition here, which we will only include animal age between 1 and 10, and only animals with gender specified as male or female, and we will also only show the species that have their average weight greater than 10 grams. And then we will finally sort the result in the descending order of the total animal. Okay, so the purpose of is this is great is to identify trends in animal population and focuses on the species that meet the specific weight and age related criteria in our VetCare hub. Okay, so for the syntax, basically we will select the species, average weight as average weight, count as total animal. Okay, from the animal table, we'll put the condition where the age is between 1 and 10 and the gender is male or female, and we will group by species. And then we'll put another condition here, which is the average weight must be greater than 10. And this is our output. This is our output, which is, you can see the species stock have the average weight of 27.58 grams. And as you can see, the total animals is for the species stock is 12. Okay, next we will be discussing aggregate function. For aggregate function, there are three functions that we use. The first one is sum, second one is average, and the third one is count. Okay, for the sum function, we want to view the total amount of payment. So for the first, as you can see, for the first one, we will select payment type, sum amount as total amount from payment table, and we will group by payment type. And as you can see from the output here, there are three types of payment type: is credit card, cash, and debit card, and the total amount is listed down here. Next, for average, we want to calculate the average cost of medication. So we will look at the medication table. We will select type, average, as in cost, and as average cost from medication, and we will group by type. You can see there are 1, 2, 3, 4, 5, 6 types of medication, and the average cost is listed next to them. For pain reliever, the average cost is $40. Antibiotic, the average cost is $25. Anti-inflammatory, $20, and goes on. Okay, for the last aggregate functions that we're going to use is count. For this, we want to find the total number of vaccine types that are inactivated. So how we do this? We select count type from vaccine table, where type equals inactivated, and the result will give us uh, the count type, which is 14 types of vaccines that are inactivated. Okay, for the last one is the joint table. This joint table is good for understanding the relationship between animal, their owner, and their scheduled appointment. So we will join three set tables. So how we do it, we will select animal.name as animal name, animal.species, owner.name as owner name, appointment.date as appointment date, appointment.time as appointment time, appointment.status as appointment status from our base table, which is animal. And then we will inner join the animal table with owner table based on the owner ID column. This will ensure that each animal is matched with their owner. And after that, we will link the animal table with the appointment table, and that will be based on the animal ID column to ensure that each animal is matched with their appointment. So as you can see from the output here, we have a detailed view of a combination of animal table, owner table, and also appointment table. So this would provide a detailed view of the upcoming or past appointments. It also would include both the animal and owner's detail for a better identification. This is also good for record keeping. That is all from me, and I think that is all from us as a team. Thank you very much for watching and listening.